Euler's theorem is a theorem that will tell us whether or not a graph has an Euler path or an Euler circuit. I'll write that. This theorem tells us whether or not a graph has an Euler path or an Euler circuit. Now, I started writing on this page like I was going to write the theorem, and that's what I intended to do, but there I just gave you a sentence about what the theorem tells us. So here's Euler's theorem. We have a graph. I'm going to write if we have a graph and the graph is connected, then there's three parts to this theorem. Number one, it has an Euler path if there are exactly two odd vertices. And in the homework, sometimes they make a real big deal about something, and I probably should make a big deal about it right here. An Euler path, but not an Euler circuit. I'll make that little note maybe at the end. I will make another little note right here. In the homework, sometimes they say, at most, two odd vertices. And these two things, exactly two odd vertices, and at most two odd vertices, do they mean the exact same thing? No. How many of you have exactly two siblings? Exactly two. So if you're raising your hand, you plus the two siblings make three people, in three siblings in your family. How many of you have at most two? That's a different question, isn't it? At most two, you could have 0 siblings, you could have 1, you could have 2. But the author of our textbook has used these interchangeably. And they're not really interchangeable. The second part of Euler's theorem, let's see, if we have a graph and the graph is connected, then it has an Euler path if there's two odd vertices. Exactly two odd vertices. There cannot be three. Number two, it has an Euler circuit if all vertices are even. Now, sometimes in the material they say this: no vertices are odd. I put it kind of in parentheses. I'll write the word or right there. I put it in parentheses just to kind of maybe have it stand out a little bit. All even vertices, no vertices are odd. Do they mean the exact same thing? Yes, they do. So this wording is okay because they do use these interchangeably. If I'm talking about this with somebody, I'm going to say all vertices are even. I'm not going to say no vertices are odd. I don't like the way that quite flows, but I want you to know those are used interchangeably, and they can be used interchangeably. The third part, okay, we have the connected graph. If there are more than two odd vertices, so let me kind of get this to flow with what I've written. If we have a graph and the graph is connected, then it does not have an Euler path or an Euler circuit if there are more than two odd vertices.